2.5. Reason using properties from algebra. Use algebraic properties in logical arguments. Let A, B, and C be real numbers. Addition property. If A equals B, then A plus C equals B plus C. This is a reason why we can have x minus 3 equals 7 and say plus 3 plus 3. Because if we take this term and add 3 to it, and take this term and add 3 to it, they're still equal. Subtraction property. A minus C equals B minus C. Multiplication property. AC equals BC. Division property. If A equals B and C does not equal 0, then A over C equals B over C. Remember, C can't equal 0 because we can't divide by a 0. Substitution property. If A equals B, then A can be substituted for B in any expression. This is the reason that we can check multiplication or algebra properties. So we can use, after we get our x equals 10 over here, we can use the substitution property to go back and check it. We can substitute 10 in for x and make sure that's a true statement. Okay, write reasons for each step. Solve 2x plus 3 equals 9 minus x. So we do each step, step by step, and then we write why we can do it. Whenever you do a proof, the first step is always given. So this is what you won't write this step. This is what you do. But you'll write these two columns. And you'll write down original problem and say given. And then we solve it. So let's go ahead and add x to both sides. And that is because of the addition property. And then what do we get? 3x plus 3 equals 9. And the reason we can say that is we can use another algebra property, and we're just combining like terms. And we can either say combine like terms, or you could say simplify. Then we can subtract 3. And we get 3x equals 6. And that's the subtraction property. Then we can divide each side by 3 and get x equals 2, and that's the division property. And so we've proven that the value of x is 2. Okay, the distributive property. A times B plus C equals AB plus BC. Example 2. Use it. Well, we can use the distributive property to multiply the negative 4 out to get us the negative 24x minus 8 equals 64. And the reason is distributive. Then we add 8 to both sides. to get negative 24x equals 72, and we use the addition property. Then we divide by negative 24 to get x equals negative 3, and we get that by using the division property. Okay, on the bottom, checkpoint. Solve these both. Start with drawing a line down the middle, rewriting your problem on the left side, and then saying given on the right side. And you'll need to write a reason for each step this time. Okay, start the video when you're done. Use properties in the real world. Speed. A motorist drives 5 miles per hour slower than the speed limit S for 3.5 hours. The distance traveled can be determined by the formula distance equals 3.5 times S minus 5. Now solve for S. Okay, first we write the given. The D equals 3.5 times S minus 5. Now what property do we need to do to start solving this algebraically? Right, we need to use the distributive property. So 3.5s minus 17.5. Now we need to get s by itself, we need to add the 17.5 to both sides. And that is the addition property. And to get the s by itself, I need to divide by the 3.5. And that's division. And we have solved for s. Okay, reflexive property. For any real number a, reflexive property. For any real number a equals a. Seems kind of strange, but we'll use it. Segment length. For any segment AB, you can also say the segment AB equals AB. And for any angle A, you can say the measure of the angle A equals measure angle A. Symmetric property. For any real numbers a and b, if a equals b, then we can turn around and we can say that b equals a. Same thing with segments, and same thing with angles. Okay. Transitive. Transitive is like the law of syllogism from our last video, and I remember this one because it starts with tran and it's kind of like train. So if one train car is pulling the next train car and the next train car is actually pulling the third train car, then the first is pulling the third. So if we know that A equals B and B equals C, then we can also say that A equals C. And then same thing with segments again, and with angles. Okay, example 4, using properties of equality. Show that C to F equals A to D. Okay, the first thing we need to do is write down our givens. And even though we don't have anything written out given, we have those little hash marks. Remember what those little hash marks means? It means that any segment that has the same number of hash marks are equal.
So AB equals EF. And that is our given. And then BC equals DE. And that is our given. So now AC equals AB plus BC. Now why can we say that? Do you remember the postulate for that? That's the segment addition postulate. Okay. And then we can also say that D to F equals D to E plus E to F. Again, that's a segment addition postulate. So now we can say that DF equals BC plus AB. And then why can we say that? We can say that because we know that up here BC equals DE. So we can substitute in. So this would be the substitution. And then DF equals AC. Okay, how do we know that DF equals AC? Because if BC plus AB equals, or BC equals AC, we have the same thing down here. So that is exactly the same as what we have right here. And so we can go ahead and say that AC equals DF because of the transitive. So now we can say that DF plus another segment equals AC plus another segment from the addition property. And then finally, we can end with we always end with the point that we want to prove. CF equals AD, because we can substitute it in. Okay, seems a little complicated, but you'll get the flow pretty soon. So checkpoint, complete the following exercises. Name the property of equality that the statement illustrates.